Classification of crystalline solids. Crystalline solids can be classified on the basis of nature of intermolecular forces operating in them. ക്രിസ്റ്റലൈൻ സോളിഡുകളെ അവയുടെ പാർട്ടിക്കിളുകളിൽ തമ്മിലുള്ള ആകർഷണബലം ഏത് തരത്തിലാണ് എന്നതിൻ്റെ അടിസ്ഥാനത്തിൽ നാലായി തരംതിരിക്കാം. They are molecular solids, ionic solids, metallic solids and covalent solids. The first type is molecular solids. In this type, molecules are the constituent particles. These molecular solids can be further classified or subdivided into three. The first type is non-polar molecular solids. The second is polar molecular solids. The third is hydrogen bonded molecular solids. മോളിക്കുലാർ സോളിഡുകളെ മൂന്നായി വീണ്ടും തരംതിരിക്കാൻ സാധിക്കും. ഒന്നാമത്തത് നോൺ പോളാർ മോളിക്കുലാർ സോളിഡും, രണ്ടാമത്തത് പോളാർ മോളിക്കുലാർ സോളിഡ്സും, മൂന്നാമത്തത് ഹൈഡ്രജൻ ബോണ്ടഡ് മോളിക്കുലാർ സോളിഡുകളുമാണ്. നോൺ പോളാർ molecular solids. They comprise of either atoms or the molecules formed by non-polar covalent bonds. As you know, non-polar covalent bonds are formed when a covalent bond is formed between two atoms having same electronegativity values. ആറ്റങ്ങളാൽ നിർമ്മിതമായ മോളിക്കുലാർ സോളിഡുകൾ നോൺ പോളാർ മോളിക്കുലാർ സോളിഡുകൾക്ക് ഉദാഹരണങ്ങളാണ് ആർഗൺ, ഹീലിയം തുടങ്ങിയവ. നോൺ പോളാർ കോവലന്റ് ബോണ്ടുകളുള്ള തന്മാത്രകൾക്ക് മോളിക്യൂൾസിന് ഉദാഹരണമാണ് ഹൈഡ്രജൻ, ക്ലോറിൻ, അയോഡിൻ തുടങ്ങിയവ. നോൺ പോളാർ മോളിക്കുലാർ സോളിഡുകളിലെ തന്മാത്രകൾ തമ്മിൽ, മോളിക്യൂളുകൾ തമ്മിൽ ഉള്ള ആകർഷണം വളരെ ശക്തി കുറഞ്ഞ ലണ്ടൻ forces ആണ്. Non-polar molecular solids are soft and non-conductors of electricity. Their melting points are very low and are usually found in liquid or gaseous state at room temperature. Polar molecular solids. These solids are formed by the molecules having polar covalent bonds. As you know, a polar covalent bond is formed when a bond is formed between two atoms that differ in electronegativity values. And so, the attraction between these molecules will be stronger dipole-dipole interactions. Polar solids are soft and non-conductors of electricity. Melting points are higher than those of non-polar molecular solids. Yet, most of these polar molecular solids are gases or liquids under room temperature and pressure. Examples for polar molecular solids are solid hydrogen chloride, solid sulfur dioxide and solid ammonia. Hydrogen bonded molecular solids. They contain polar covalent bonds between hydrogen and fluorine, oxygen or nitrogen atoms. These polar bonds are much stronger and leads to the formation of hydrogen bonding. Example for this type of molecule is water. These hydrogen bonded molecular solids are non-conductors of electricity. They are volatile liquids or soft solids under room temperature and pressure. Ionic solids. In ionic solids, ions are the constituent particles. These are formed by three-dimensional arrangements of cations and anions. The attraction among these particles or the ions are much stronger Coulombic or electrostatic force of attraction. Ionic solids are hard and brittle in nature. They have much high melting and boiling point values. In molten state or when dissolved in water, they conduct electricity. Metallic solids. Metals are orderly collection of positive ions surrounded by and held together by a sea of free electrons. These electrons are mobile and are evenly spread out throughout the crystal. These free and mobile electrons are responsible for high electrical and thermal conductivity of metals. Metallic luster and color shown by metals are also due to the presence of these free electrons in them. Covalent or network solids. These are crystalline solids of non-metals result from the formation of covalent bonds between adjacent atoms throughout the crystal. These solids are also called giant molecules. Covalent bonds are strong and directional in nature. Therefore, atoms are held very strongly at their positions. These covalent solids are very hard and brittle. They have extremely high melting points and may even decompose before melting. These covalent solids are insulators and do not conduct electricity. Examples for such solids are diamond and silicon carbide. Like diamond, silicon carbide, graphite is also a covalent network solid. But its properties are little bit different from other covalent solids. Unlike diamond, graphite is soft and a conductor of electricity. Its exceptional properties are due to its typical structure. In graphite, carbon atoms are arranged in different layers and each atom is covalently bonded to 3 of its neighboring atoms in the same layer. The 4th valence electron of each atom is present between different layers and is free to move about. These free electrons make graphite a good conductor of electricity. Different layers of graphite can slide one over the other. This makes graphite a soft solid and a good solid lubricant.